Hello everyone, Mr. Dempsey here. Today we're going to be talking about how modern taxonomy reflects evolutionary history, which is video 7-4. And let me introduce you to Carl von Linné. He is a Swedish doctor and naturalist back in the 1700s, and one of his hobbies was botany, the collecting of plants. And he was frustrated by the fact when he would write about his plants and publish that, other people outside of Europe would have trouble understanding his classification systems. So one thing that he developed was a grouping called taxonomy, in which what we have down here, here's all living things, and within that we have different domains, something that was added to later after Linnaeus, and then he used these groupings here, kingdom and phylum. And as we go down specifically, you can see with the example with dogs, we're getting more and more specific. So we start off as a very inclusive grouping, so domain eukarya, anything with a nucleus. As we work our way down, we're excluding some types of eukaryotes, such as plants and animals, and we're going down into now animals, and then into the kingdom, into the phylum rather, chordata. These are animals that also include vertebrates, animals with backbones, and mammals, and so we're getting more and more exclusive as we get down to just one grouping left, and that is the species Canis lupus, which actually means wolf. But that also includes dogs, since dogs are a subspecies or a descendant of wolves. Another thing that Linnaeus developed was this binomial nomenclature system in which a species is given two names. The genus name, here you can see it with Canis, and then also a species name, lupus. And he used a Greek and Latin naming system because even though he was Swedish, he understood Greek and Latin like many educated Europeans at the time. And so that would be a way to almost translate the word of meaning. So like Homo sapien means intelligent man in this case. All right, now let's move on to how traditional classification compares and contrasts with modern taxonomy. So traditional taxonomy is focused on physical similarities and differences among species, whereas modern classification uses a wider range of characteristics, including DNA, to understand how species are related by common ancestry. So let me have you pause and think, are crocodiles, as depicted right here, are they more related to lizards up here, or are they more related to birds? So I'll have you think about that for a second. So are they more related to lizards, including all these other groups up here, or are they more related to birds? So let's think about that. If you say that they are more related to snakes and lizards and things like that, then you would have your grouping, your phylogeny, look like this. However, if you think that crocodiles are more related to birds, then you would depict something like this. The answer, of course, actually might surprise you that crocodiles are more related to birds than they are to any other, quote, reptile, such as snakes and lizards and things like that. And we're going to talk more about that in a few moments. One thing we can also see in our phylogeny is this grouping here of birds and crocodiles. Right now, you notice birds are on the bottom, crocodiles are up here, but I can flip those with having birds at the top and crocodiles down here. The information actually is the same, even though I flipped them around. It shows that birds and crocodiles share a more recent common ancestor than if we go all the way back here, where crocodiles and birds, rather where those two groups, crocodiles and birds, share a more distant common ancestor to snakes and lizards. So if I flip it around again, it's the same meaning as this. That does not change things. It almost means, if you think of a hanging mobile, one of those art sort of projects where you see this thing sort of dangling and spinning, if we take the birds and alligators and move them back and forth, this is what we're seeing. It's almost like rotating around this node right here. And so the groupings don't change when we flip them like that. So moving on. Now let's look at how phylogenetic trees can be used to evaluate how species are related. Okay, so we've already talked about how birds and crocodiles are surprisingly related. Let's look at some fossil evidence that might give us shed some light on that idea. So Mesozoic birds have reptilian traits. Here we're looking at a creature called Archaeopteryx, which lived back in the Jurassic period. And there's some features about it that make it very unbird-like. So birds, as you probably realize, have feathers and wings, such as Archaeopteryx did. But what's very unbird-like is this long bony tail, which birds don't have today. Also teeth, which Archaeopteryx has. A little hard to see in the picture there, and they also have fingers with claws, something you wouldn't really see on a bird with, you know, sharp claws dangling off from the wings like that. But Archaeopteryx had all those features, making it maybe a link to reptiles, perhaps, in this understanding. So now we're going to build on this idea a little bit. So we're going to look at something called a cladogram. So a cladogram is where we use lists of characteristics. It could be molecular or anatomical or other types of data. Here we're using anatomy as a way to understand how various groups of animals are related. We're using our familiar groups from before, the birds, crocodiles, and so forth, but we're going to also add frogs to this list and fish. So to start off with, one thing that they all have is a backbone, a vertebrae. And so if we were to think about where that characteristic would be, it would be back here, which means that all the descendant animals from this common ancestor have inherited a backbone. We might call that a primitive character. A primitive character is something that is widely shared among various groups, species in this case, and it's viewed as having evolved long ago. Now we're moving on to forelimbs. So forelimbs, now we are no longer including fish. Fish do not have forelimbs, whereas all these other creatures do, including our frogs, forelimbs. Birds, they've got 2 legs. Their wings are included in those limbs, so that's 4. And of course, all these animals here have 4 limbs as well. Moving on, we've got shelled eggs. So reptiles and birds have a shell around their the developing baby, which prevents that animal from drying out on land, whereas amphibians lack that characteristic. And you can see that frogs precede that shelled egg, so they have not inherited that trait, whereas shelled eggs is here. All the descendant animals have inherited that trait. 4-chambered heart. So that's something you might think of with mammals, but believe it or not, birds and crocodiles also have that trait as well. That might be an example of something called parallel evolution, or maybe you could think of it as convergent evolution, where unrelated groups have evolved something similar. And then finally we have feathers. And feathers is something that is unique to just birds. But think about this, in terms of the evolution of birds, you might wonder, if you look back in the fossil record, what kinds of animals may have existed between the crocodiles and the birds, maybe extinct groups of animals, including Tyrannosaurus rex and velociraptors. You might wonder if they too had birds, if they too had feathers, rather. So finally, this idea of feathers, we could call that a derived trait. That's something that has more recently evolved. In this case, today only birds have feathers. And finally, moving on to our last topic, we're looking at how a modern classification system includes higher taxa, domains. Okay, so domains would be the largest taxonomic group above kingdoms. So for example, we can see animals and fungi and plants. Those are different kingdoms, and within that, those kingdoms, I should say, are within this group called Eukarya. At one time, when I was in high school, bacteria and archaea were also one group, one kingdom. They're called Monera, but today they're recognized as being 2 very distinct groups, and so that they actually contain their own domains. Archaea is a domain as well as bacteria, and you can see there's specific groups within those as well. So overall, we see domain, which includes our Eukarya, archaea, and bacteria. We can move on to kingdoms, such as plants and animals and fungi. Moving down, we have our phyla, such as with the example with the wolf and the backboned animals, the chordates, and so forth. So that is it for our classification video, and let us know if you have any questions. Thanks for watching.